Okay, let's unpack this. Portland, Maine, you think stunning coastlines, incredible food, and, well, let's be honest, a fair bit of rain. What if that very rain, usually something we just, deal with, could actually become a powerful new source of energy? I mean, how do you even start turning falling water into electricity?
Yeah.
It sounds futuristic.
It does sound a bit like science fiction, but it's real science. And that's the exact question driving this deep dive into rain-powered solar. It's a cutting-edge hybrid energy blueprint really designed for places like Portland, which get both decent sunlight seasonally and quite a lot of precipitation.
Right.
So our mission here is to break down how these innovative systems actually work, their potential for local energy resilience, and naturally the hurdles we need to clear.
And we're drawing on a specific source for this.
Yes, a comprehensive white paper. It's called Rain-Powered Solar Panels in Portland, our white paper. It basically blends the tech innovations with Portland's specific climate and economic factors.
Okay, so let's get to the core of it. How do you do it? What's the aha moment, the tech that turns rain into actual power?
Well, it's pretty ingenious, actually. The core technology involves something called triboelectric nanogenerators, or TINJAWs for short.
Who'd you say?
They use the triboelectric effect for the static electricity, basically. They generate a charge from friction. In this case, it's the kinetic energy of raindrops hitting a surface.
Just the impact of the water.
Exactly. The innovation is placing these special transparent polymer layers, think flexible, clear plastics, and some conductive coatings right on top of standard solar panels. So sunlight still gets through for the solar part. But the 10 layer captures the energy from the raindrops hitting it. They've even found that grooved surfaces, kind of like the texture on an old DVD.
Really? Like a BVD?
Yeah, apparently that texture helps trap light better for the solar panel, and it boosts the electrical output from the raindrops. The lab prototypes are showing real, measurable electricity generation per panel. It proves the concept works.
Wow. Friction power. It sounds almost too simple, but clearly very clever. And you mentioned something interesting earlier. Solar panels work better in the cold.
They do, yeah. Solar panels can be 10–25% more efficient in colder temperatures, like Maine's winters, compared to, say, hot desert climates.
So that makes Portland seem even more suitable, right? The cold helps the solar, and then the rain helps the tang part.
Precisely. Portland gets, on average, about 4.6 peak sun hours daily, but that's an average. It varies a lot. Summer and spring are strong for solar.
But fall and winter dip way down, I bet.
Exactly. Output can drop quite significantly, and Maine gets, 40 to 50 inches of precipitation a year? Lots of rain, sometimes snow.
So the hybrid system kind of smooths things out.
That's the idea. It provides a crucial supplement during those low sun, rainy, or snowy periods. It means more consistent power, which directly tackles Portland's energy resilience challenge, especially with that variable weather.
Okay, so the lab results are promising. Portland's climate seems, well, perfect for it. What's stopping us from seeing these on rooftops everywhere there?
Right.
What are the real-world hurdles?
All right, moving from lab to rooftop is always the tricky part. There are some significant barriers. First off, cost.
Figured that might be one.
Yeah, these hybrid systems are estimated to be maybe 20–30% more expensive up front. You've got the extra materials like graphene, specialized polymers. The 10 components themselves add a chunk of cost, maybe $10,000 to $15,000 per system initially.
Oof, okay. What else?
Roof compatibility, especially in a place like Portland with older housing stock. Some roofs might need structural upgrades to handle the panels plus snow load, and Portland has pretty strict regulations about that.
Decent.
And then there's grid integration. Current net metering policies where you get credit for excess solar energy send back. They're set up for solar.
Not for this dual harvesting thing.
Exactly. There aren't specific incentives yet that recognize and reward the extra energy generated from rain. So the financial payback isn't as clear-cut as traditional solar, which can have a 4–6 year payback in Maine already.
So it sounds like the promise is definitely there, but we need some intentional steps to make it practical. If we do overcome these hurdles, what's the big picture impact?
Oh, the impact could be really significant. Think about existing large solar arrays like Wyman Solar Farm up in Washington County. Imagine optimizing its output during Maine's notoriously rainy harvest seasons.
Right, keeping the power flowing even when the sun isn't strong.
Exactly. Long-term, say over 25 years, analyses suggest hybrid systems could cut grid dependence in rainy regions by maybe 40–50%. We're seeing related Tang tech work well elsewhere too. MIT used it for desalination with high efficiency in the lab. Soochow University had field tests combining Tangs and solar.
Are there downsides to the Tang part itself? Like, does it last as long as a solar panel?
That's a good point. The Tang polymers might degrade a bit faster than the solar panel itself, maybe around 1% annually compared to solar's 0.5%. And recyclability of these newer materials is something else to consider. But the potential for consistent energy, even with slight degradation, is still pretty compelling.
Okay, so wrapping this up, what does this mean for the future? What needs to happen to push this forward?
It really comes down to strategic investment and supportive policies. We need state-level programs, maybe expanding things like Maine's Solar for All initiative to specifically include R&D for hybrid tech like this.
And fixing that net metering issue.
Definitely. Reforming net metering to give premium credits for this dual harvested energy would make a huge difference economically. Technology-wise, researchers are looking at integrating Tangs with next-gen solar cells like perovskites.
Which could boost efficiency even more.
Potentially up to 25% combined efficiency by 2030, some projections suggest. And you could imagine community microgrids pairing these hybrid systems with, say, small-scale hydro. But really, community engagement is key too. Educational workshops, pilot programs, maybe testing arrays in really high rainfall spots to get hyper-local data. That builds understanding and adoption.
So these rain-powered solar panels, they're clearly more than just a cool idea. They genuinely seem like a transformative opportunity, especially for places like Portland, to boost energy resilience by, well, using the weather they have, turning rain from a challenge into a resource. It makes you think, doesn't it? As we look at our energy future, how else could we rethink our relationship with things we see as unfavorable like rain? Could they actually be untapped resources just waiting for the right innovation?
Yeah.
And thinking about policy, what kinds of support do you listening now think could really help unlock technologies like this? Something to ponder.